Next, we're learning about approximation. Approximation is pretty simple, pretty easy, pretty straightforward. So we're going to go through this pretty fast. All approximation is you use a tangent line to estimate a point of your function line. So if you have a function and it looks like this, and you pick this point right here and you make a tangent line, it's going to look something like this, right? This is going to be your slope at this one point. This is your tangent line. So approximation just means that if you're trying to find this point right here, I mean, you could use this point right here on your tangent line because it's pretty close together. And it's saying that if you're trying to find this point, you could use this point, and it's going to give you a pretty good estimate of what it is. And the further away that you go from your original point that this tangent line is for, the further away from the actual function that your approximation is going to be. One thing that you have to know before we get into actual problems is that if your function is concave up, like this left part of this function over here, whatever your approximation is going to be an underestimate of the actual value because it is under the line. And if it is a concave down graph, like this one on the right, whatever your approximation is going to be an overestimate because it is above the line. And if you don't know what concave up and concave down is, we go more in depth about that in Unit 6, but we should have covered the basics in pre-calc. Concave up looks like the cup. Concave down looks like a frown, right? I just think of it as swooping upwards, swooping downwards, concave up, concave down. Let's get into some problems. This will be real fast. Okay, so this problem here, it says the function f of x equals negative x squared plus 16 is concave down at x equals 5. What is the estimate for f of 5.1 using local linear approximation for f at x equals 5? So this is giving us a function, and it's stating that it's concave down. That means it's like a frown, it's downward, right? The linear local approximation, what this means is we're going to find the tangent line at x equals 5 and then approximate where 5.1 is at. So the first thing we have to do is find the tangent line. So the equation that we use to do this is point slope form. Y minus y1 equals m times x minus x1. So we have to find our y value and our x value. We have our x1 right here, it's 5, and we have to find our y1, so we plug 5 into our original equation. So once we plug 5 into our original equation, we get negative 5 squared plus 16, so negative 25 plus 16, or 9. So our y1 is going to equal 9. I'm speeding through this because this isn't the calculus part, this is the review part. So now what we're left with is y minus negative 9 equals m x minus 5. Because we have our y, we have our y1, which is what we get when we plug in 5. M is the slope, we haven't found that yet, and then x, and then minus 5, which is our original x value. So now we have to find the m here, we have to find the slope, which just means we have to derive this, and we get negative 2, and our x equals 5, so we'll plug 5 in, and we get negative 10. So our slope here is negative 10. So our equation is y plus 9 equals negative 10 times x minus 5. So this is going to be our equation for the tangent line. If you wanted to, you could multiply this out, distribute the 10, and then move the 9 over. That's just really unnecessary because it's kind of work that you just don't have to do. So if we're trying to find the estimate for f of 5.1 using this equation here, all we have to do is replace our x with 5.1 because we're using our tangent line here. We're not using our original function. So if we use our tangent line here, we get y plus 9 equals negative 10 times 5.1 minus 5, and then inside the parentheses, subtract that, you're just going to get 0.1. So you have y plus 9 equals 10 times 0.1. 10 times 0.1 is just 1. So y plus 9 equals 1, and we'll subtract the 9 over, y equals negative 8. So the value of f of 5.1 using our local linear approximation line is negative 8. Or if you wanted to, you could write 5.1 negative 8, and that would be the actual point value. This is pretty much it for this concept. It's very fast, and you rarely ever use it. And it's also pretty straightforward. You just make the tangent line and then plug in your x value. So we're going to move on. This video will be short. We'll move on and cover the next one.